So I'm trying to see if puro pa kasi mga introduction eh. So I think okay lang ba sa inyo at least Dr. Patolina's talk live stream pag siya na? How would you say that? Are you familiar with the Philippine Chemistry Congress? Have you attended one before? Or have you presented in it?
Attendee lang po.
Attendee lang? Hindi kayo nag-present? Maganda kasi yung PhilChem Congress kasi nakaka-out of town. Pero ngayon, virtual lang. But there's a registration. Okay? And I'm not sure, 1,000 pesos ata yung attendance, yung registration fee. Okay? But me as a speaker, so binigyan nila ako ng access. So I was surprised. Ngayon pala yun. I didn't know that it will start today. Okay? But everything is recorded because I submitted my talk, I think 2 weeks ago. Masyado silang strict. So, trying to find, ito na.
For the presentation, and the remainder of the time, 10 minutes, devoted to question and answers. Participants may forward their questions or inquiries to using the community chat feature of the platform. The first plenary speaker this morning sets the tone of the conference. He will talk about how COVID caused significant disruptions and how it also provided the opportunity to reset our societal goals as we approach 2050. Our speaker is no stranger. He is a Bachelor of Science in Agricultural Chemistry graduate of UP Los Baños, graduated magna cum laude, and has a PhD in Botany Phytochemistry from the University of Texas. He has a long career in the academe, holding various administrative positions at the UPLB, from chairman of the Department of Chemistry to vice chancellor for academic affairs. And he also served the government in various capacities, including as secretary of the Department of Science and Technology. A member and former president of the National Academy of Science and Technology, please welcome Professor William Gonzalez Padolina.
Thank you, Eric. Can you hear me? Hello.
Yes, loud and clear, Dr. Padolina. Please
Okay.
proceed.
Thank you, Eric, Dr. Ponsalan, and thank you for this kind invitation to the officers of the PFCC and its members to share a few thoughts about how we might build back better through chemistry after we are able to overcome some of the obstacles brought about by this pandemic. And I have the first slide, please. It's just the title, which connotes the prospects of the futurization of chemistry in the Philippines and making tomorrow actionable. Next slide, please. Eliard, I'm unable to see it in my screen.
Hi, sir. Good morning. Are you in the WebEx app?
Yes.
Who is screen sharing? Ikaw ba, Nick?
Yes. What screen are you seeing, sir?
Myself.
Yourself?
Uh, is there a layout button on the upper right corner of your screen, sir?
Let me see. Nothing.
Two buttons. One
So
is for
medyo
sign up, the other
may
one is
technical
for
ano sila.
censoring
That's I
myself.
think the problem when you're doing it live.
Anyway, we can proceed on.
Andito na si Anthony. Ayun, kumpleto na tayo. Okay lang ba sa inyo manood or ayaw nyo? Because this is free. So that's why I said, oh, maybe I can live stream it kasi may access ako. Kung ayaw nyo, edi mag-aano na tayo. Yun yung mahirap kapag live yung talk, pag technical problem, on the spot nila aayusin. Okay? Okay lang sa inyo? Okay, sige. Ano yun natin uli? Si Sir WGP. Yan ako yung volume eh. But
Other chemistry
buffering.
professions. Next slide, please. Let me deal first with the drivers of change and the challenges of the 21st century. There are many of them. We are not able to cover all of them, but I hope this flags the many complex situations that we need to confront. And there is no longer room to look at a one-size-fits-all approach. It is not possible to solve these problems by just looking at one way of looking at all of them. We have to accept the complexity of the situation. And the more we simplify things, the farther we are from the solution. Next slide, please. Let me just appraise you of the latest key findings as reported by NEDA on the impact of COVID-19 on our economy. The most important, of course, is its cost to our present and future activities. The long-run total cost is estimated to be at 41.4 trillion pesos in net present value terms. In 2020 alone, it cost us 4.3 trillion. But the more concerning thing is that it will take a bit of time before we will be able to recover. And that's 10 years from now.
Even to the pre-pandemic growth.
Now, this should disturb all of us because that's quite a long time. And I don't know whether we can cope with that, both personally, economically, and as a nation. Next slide, please. So this really brings us to an excellent opportunity to build back better, to reset our ways, embark on the paths of genuine change, and be willing to make choices. That means some of the things we're doing now will have to close. We will have to retool. We will have to reorient. And we have to have the courage to say, no, we have to cut this. We have to go this way because it's not going to take us anywhere. And it's not consistent with the path of sustainability. The question, next slide, please, of the human environment is not new. In fact, we are this year going to observe, or we have observed, the 50th anniversary of the first conference conducted by the United Nations on the human environment. That was in June 1972. And there, and I recommend you read that document because it contains a lot of things that we should be doing, that we should have been doing. But it took another conference in 1987 under the chairpersonship of the Prime Minister, former Prime Minister of Norway, Gro Harlem Brundtland, which now is the living document for sustainability. So please take time to read the two, because there are many challenges for science that are stated. And unfortunately, even if we are already at the 50th year of the first conference, things are getting worse. Next slide, please. Now, let's take up the issue of sustainable development. And as a chemist, harmonize the aspiration with the science. In other words, how do we operationalize? The next slide, please. The definition that it should not compromise the ability of future generations to meet their own needs, but also take cognizance of the two concepts. One is that sustainability has to give priority to the needs of the world's poor. And second, the idea of limitations, most of which we have really taken for granted. Because whenever we cite this particular definition, we stop at the first sentence, which is for future generations to meet their own needs. But we should read the document and see that there are two other components which we need to address. Next slide, please. And what I'd like to impress upon everyone today is that there needs to be a scientific basis for this aspiration. And what are these two scientific bases which can be gleaned from these two documents? First is that as scientists, we must be able to define, and as chemists, on the molecular basis, the Earth's ability to regenerate itself, which is also called environmental resilience. And second, define also on a scientific basis with certain indicators, and as chemists on a molecular basis, the Earth's ability to absorb waste. Because we need to confront and manage potentially irreversible changes at the boundaries of restricted opportunity space. Next slide.
It is also very important for us to realize that to produce from nature is to change nature. No way will we be
able to keep the pristine condition once we produce from nature, whether if we are producing food, whether we're doing it using conventional farming or organic farming or urban farming, we are changing nature. And if we are exploiting our natural resources from the aquatic bodies, the marine and freshwater resources, from our mineral resources, we change nature. Next slide, please. And how do we do that? Because we are part of the Technosphere. And let me focus on our part as chemists of the Technosphere, which is the local and global chemical industry. Let me first make sure we are on the same wavelengths when we define Technosphere. And here I offer the suggestion or the definition by the originator of the term, Professor Huff. The Technosphere is the interlinked set of communication, transportation, bureaucratic and other systems that act to mobilize fossil fuels and other energy resources. And this is considered to be an emerging global paradigm, which we probably need to accept by now, with similarities to the other spheres, like the lithosphere, the atmosphere, the hydrosphere, and the biosphere. In other words, we need to recognize it's part of a system, and we need to manage it as part of a system. The proliferation of technology across the globe defines the Technosphere. Next slide, please. And the next slide just gives you an example of how far we have gone especially with regard to the exploitation of rare earths, iPods, wind turbines, fiber optics, energy efficient fluorescent bulbs, etc. Next slide, please. And the Philippine chemical industry is characterized by the Department of Trade and Industry. It's the third largest manufacturing subsector. And we produce about 330 billion, produced in 2009, 330 billion. I'm sure this is much more in recent years, but the combined chemical imports and domestic production of our chemical industry is close to 14 billion. Now, reduce that into products and reduce the products into molecules and see how we are able to introduce these cells to Philippine society. Furthermore, there are 1,400 registered chemical manufacturing firms employing 93,000 personnel. I don't know where they are now with the COVID. There are 32,000 chemical professionals and over 360,000 engineering students enrolled every year. And as a throughput, 60,000 graduates. 33 universities offer chemical engineering, and 50 schools offer chemistry. Next slide, please. This is just an overview of the kinds of products that our local chemical industry are engaged in. The ones that are shaded and bordered with red are where we are active. And you see, for example, in the case of commodity chemicals, we're active there. Intermediate chemicals, we're active. And in marketing and sales distribution. There are gaps like basic chemicals and specialty chemicals, which we need to probably think about as we undertake our research. In fact, many say that the problem that we are facing in advancing our pharmaceutical industry, for example, is that we do not produce and we do not have access to fine chemicals, which is a building block for new molecules and eventually drugs. Next slide, please. Globally, there's a very interesting document that I like for all of you to access, and it's the Global Chemicals 2 Outlook of 2019 that was published by the United Nations Environmental Program. And you can see from here, the chemical industry is huge. 5 trillion in 2017 and expected to double by 2030. I don't know how COVID will have affected that, but it is driven by many, many things: construction, agriculture, electronics, and hazardous chemicals and other pollutants continue to be released in large quantities. Next slide, please. Furthermore, the chemical industry is a significant source of greenhouse gas emissions. We release waste from waste dumps, sources of air pollutants. Hazardous chemicals are also released indoors. I don't know if you have noticed when you buy a new car, you smell strange things, which eventually diminish, but for about a year, you're there inhaling a lot of these things. This has been analyzed, and it's interesting to see what kind of vapors you are taking in. Furthermore, we also release to water bodies and to the soil. Next slide, please. And there are many products where we are able to introduce molecules into the environment, volatile or semi-volatile. And they come from products like, cosmetics, your personal care, your packages that you use for food. And in fact, there are studies on how the molecules from these packaging things move into the food. And also, of course, when you move these products transport them throughout the world, you are in fact accumulating human-made material stocks. And if you don't handle them, they will be persistent and remain where they are brought. Furthermore, there are releases from municipal and hazardous waste. I don't know if anybody has studied Payatas, the garbage dump, or any of the landfills. But solid waste recycling is fortunately being taken cognizance and is increasing throughout the world. The next slide shows you just what we need to be worried about. And that is some estimates of a proposed boundary beyond which we already exceed what the two components of a science-based sustainability effort would be. Number one is the Earth's ability to regenerate itself. And second is the Earth's ability to absorb waste. I don't know when you propose a research proposal, whether you take these two into consideration. What will happen to the new molecules that you produce? What will happen to the new devices that you are able to put together? What will happen to the product that you are able to patent and sell and commercialize when its life cycle becomes obsolete? And there are many examples that we now face with this particular concern because of the activity, the intense activity of the technosphere. And here you can see some boundaries that already have been exceeded, especially those affecting climate change. And I also recommend you read this particular paper by Rockstrom, because he has done a lot of things on how we can look at the carrying capacity of the Earth in view of these two very important concerns on the scientific basis of sustainability. Next slide, please. And in fact, based on an estimate, we have already exceeded what our Earth can regenerate this year. And that point fell on July 29 this year. So even with COVID, we have already exceeded, and COVID has already reduced very much a lot of our activities. And this should be a point of concern, because if you look at the time series graph of this, there is a every year an earlier date where we exceed our ecological resources and services that can be handled by the regenerative activity of the Earth. Next slide, please. So, are our environmental concerns solvable? And can we restore the natural world that has been domesticated? Next slide, please. The proposal, and this is not mine alone, is to look at establishing, all of us, a circular economy. And it's not just the circular economy, we have to have a circular lifestyle as also. Next slide, please. Now, many of those who have analyzed the technologies that are available now in this particular century say that the heart of all of this is the molecular revolution. This is a book by Juan Enriquez, a professor at Harvard, one of my favorite readings, and the title is As the Future Catches You. And again, I recommend you look at this as you try to now reorient your thoughts about what to do with chemistry, what kind of research to undertake, and what kind of concepts to teach to our students. Next slide, please. There are new game changers, of course. You recognize this, and some of you are already engaged in this. Biotechnology, nanotechnology, and material science, sensorization, big data, artificial intelligence, autonomous systems, neuroscience, study of the brain, learning engineering, and sorry, I missed it. It's another one is space science. Next slide, please. But having all of these tools in our hand, we have to be aware of the conditions for human productivity. That health and wealth are completely dependent in the way we handle natural cycles. And that a large portion of the raw materials that we have now extracted have affected our environment. And it is essential to remember that such disruptions may be fatal for us. It is essential that the cyclic flow of materials are the basis of perpetual processes. It is the waste. If the wastes are not recycled, no process can be sustained and it will come to an end. But come to think of it, it's all molecules. It's all molecular. Even the Earth's way of regenerating itself is going to be monitored on a molecular basis. Next slide, please. So this is now the circular economy, which talks about raw materials being processed through a production process. And you can see an internal recycling process. These products are then moved to the consumers. They have the consumer products. And you again are confronted with the reuse of these products. There is, of course, not 100% opportunity to reuse. You have wastes, and the waste go to waste management as well as waste from production, which are then managed to be recycled. And the recycling process also produces something that needs to be managed as waste. And in an ideal situation, hopefully this will be realized, we can recover material to input again to the production process. There are many cycles that you can see here, and that is for us to define and for us to understand and for us to provide the information so that they can be managed. There are unidentified health risks. There are environmental risks. And we also do not know completely the kinds of molecules that we are able to produce and release to the environment as we go through these different processes. Next slide, please. It is important to appreciate the value chain of the chemical industry and the kinds of molecules that we emit and release to the environment. From the time we extract our raw materials to the time we process and manufacture, and then feed whatever intermediate products to a downstream chemical product manufacturer, convey it to the consumer, and the industrial and consumer products use it and hopefully reuse it, and the industrial and consumer products have to be disposed and considered as waste. How do we tie all of this in so that we see a cycle that is consistent with the rhythm of activities of the Earth's ability to regenerate and its ability to reduce, to absorb waste? And here is an interesting example of paper. Do we know that when we dispose of this, and because we are heavy users now of paper with many LGUs banning the use of the single use of plastics, that we generate mineral oil hydrocarbons, phenols, phthalates, PCBs, and metals as we are disposing of these paper products. Um, what kinds of molecules they are in terms of very specific compounds we need to define. Next slide, please. And again, this shows how these different components in terms now of human activities interact and how they are very closely related, both in terms of supply and demand. And at the end of the day, they have an impact on the recycling and waste sector, whether they are input or output users of the recycling sector. The consumers here are identified as a main supplier of materials for recycling and waste. But note in this diagram that there is a box for final disposal. And that is what we need to understand. Next slide, please. This is just to show you that whatever activities we undertake as chemists to try to preserve the integrity of the environment is related to all the 17 Sustainable Development Goals. Unfortunately, we don't have time to dissect all of these impacts, but this shows you there is not one of them that we are not going to have an impact on. And so the responsibility is heavy for us. Next slide, please. And that brings us to the concept of sustainable chemistry, which is the design, manufacture, and use of effective, efficient, safe, and more environmentally benign chemical products and processes. This is a big challenge because some of the products we are producing now do not satisfy this or satisfy only parts of this, and we have to undo some of these legacy tendencies. And here, the products are the use of renewable and recycled feedstocks. In fact, there is one thought in many of the discussions I have attended that we should only extract molecules once from the earth. That means we reuse it and recycle it. Increased energy efficiency and avoidance of substances that are persistent, bioaccumulative, and toxic. Now, having all of these concerns and all of these tools and all of these suggested directions to take, how do we set the stage for the reset? And here, again, I propose we establish the science base for a circular economy. Because as chemists, you will not deny that now we have tools that will allow us to see more, detect more, and to sense more. What a very powerful set of capabilities. And why don't we use it so that we are able to assure the sustainability of human life in this planet? This requires long-term thinking. And this is not easy to do, but we need to be able to engage in it and participate in it and share our thoughts about it. It cannot be business as usual. And as I said earlier, we have to be prepared to make hard choices. We have to be prepared to bite the bullet because we can no longer conduct these things the way it's being conducted, the way we are contributing to the hastening of global warming, which is coming back at us because we are experiencing extreme weather conditions now. Next slide, please. And that is the circular economy. And our contribution to the circular economy is to be able to provide information on biogeochemistry, which is the basic basis for recycling. Next slide, please. This is a very interesting diagram by the winner of the Japan Prize in 2010, Professor Vitutsek of Stanford. And look at how human activities in industry, agriculture, have impacted on just some of the basic elements like carbon and nitrogen, and how they contribute to the impact of global change and the loss of biodiversity. Next slide, please. Biogeochemistry is defined as the study of how chemical elements flow through living systems and their physical environments. It investigates the factors that influence cycles of key elements such as carbon, nitrogen, and phosphorus. There are two important points here. For us chemists to understand how we will conduct experiments and research in biogeochemistry, we need to be conversant with two basic disciplines. One is our own chemistry discipline, and the other one is biology. This should flag an opportunity to those designing curriculum in chemistry that we should have more biology, because in fact, we are now in a digital biogenomics age. And we cannot handle biogeochemistry if we don't understand living systems, the molecules of the living systems, how they interact, how they are metabolized. Next slide, please. And this shows you just an example of the kind of focus that we can look at. Looking at non-point sources, which is very difficult, and point sources of pollution. And this is just pollution for water. We need to attend to air. We need to attend to the soil. Look at just how wide the agenda could be, and look at why we need to rethink about what we're doing now. Next slide. And this shows you again the system that we have to deal with. Aside from these four, you need to add the technosphere, which perturbs many of these as we now know. Next slide, please. And these are just some examples of the long-term experiments and research that is taking place in biogeochemistry. And the need, next slide please, to deploy sensors. One of them could be biosensors that will allow us to monitor changes in the environment, changes in concentration of molecules in different systems, and how we will be able to process the data. Furthermore, we have the mechanism of biodegradation, which is really a system where we think about materials being transformed, and the transformation is catalyzed. And finally, we have a degradation system. But next slide, please. These are mainly microbially mediated processes. There is a pervading view that it is very slow. And next slide, please. We must be aware that not all biodegradative processes produce safe molecules. In fact, there are papers already which have been published that show that biodegradation may in fact be more harmful if not done with the proper microorganism or the proper system. And here you have the different functions of the microorganisms, which you all are aware of: bioaccumulation, ion exchange, precipitation, surface complexation, etc. Next slide. And there are many unusual microorganisms. And this has been my call to the biology sector. Revive our microbiology curriculum and our capacity to study microorganisms. I think they are going to be the main tools of future sustainability. The more we understand them, the more we're able to identify them, the more we are able to see the wide variety of genetic material that we can now transfer and move around so that we can increase the capacity of natural systems to cope, not only adapt, but also mitigate the effects of environmental degradation. Next slide, please. For example, you have a microorganism that uses carbon dioxide as the sole source of carbon. And let me now move on to just a specific proposal so that we can also generate new wealth while we are looking at the environment. And this is the potential of biocommerce, to try to orient the way we handle our biological resources so we can produce high-valued goods through sustainable processes. And this is a diagram which tells us the potential of biological materials, what kinds of products we can produce, pharmaceuticals, chemicals, feedstocks, flavors, and fragrances, and just a proposal on how we might manage a biocommerce value chain by making sure we are aware and we have a correct reading of the market, and that the production of the goods will fit the needs of the market. But it has to go through a very rigorous process of not only analysis, but also toxicological and metabolic clinical tests, and also to try to breed elite varieties from our biological resources by making sure we have the genome, we know the genome of these different sources. And you can see from the next slide the various sources that we now are able to tap. But I am sure a very small percentage of them have their genomes defined. The biocommerce market, as it is now, is really one that addresses health and wellness, taste and well-being, fragrance and beauty. Next slide, please. Next slide. And the emerging applications of biological resources are many, but let me focus only on a few. First is oleochemicals. I don't need to explain this. Many of those attending our convention or conference now are from this sector. The global oleochemicals market is huge and expected to grow further. And we have the coconut as a material for us to participate significantly and reliably in this market. The next slide shows you other applications of oleochemicals. It is wide, and I'm sure we can find more of them. And very few of us realize that we have a unique material in our hands, and that's the 15% content of medium chain fatty acids in coconut oil. And next slide, please. And the next slide is the composition of coconut oil. Again, I'm showing this because I don't know how many of us have analyzed the minor components of coconut oil, the monoacyl glycerides, the phospholipids, the glycolipids, the sterols, and the tocopherols. We always talk of them, but I have yet to see a publication that shows the structure of all of these, the molecular nature of all of these. Next slide. The medicinal plants. we are active participants in this. According to DTI in 2011, we had a contribution of about $153 million. And the major contributor are the medicinal plants. This next slide, please. Next slide. And the uses of the approved medicinal plants by FDA are 10. I don't know how many of them have already been commercialized. But my concern is really the identification of the active components, whether they are synergistic or whether they act alone. A lot of work still has to be done. Otherwise, how can you standardize the products if you don't know the active components? Next slide, please. Drugs from marine sources. We have active participation in this. Those that will be able to replace morphine without the side effects, like a seconotide, and another marine drug that is derivatized, eribulin, for some ailments. Colorants, very few have really gone into this market. It's a big market too, and growing. And for now, next slide, please. Next slide. We have a few of our biological sources that we can tap. Achuete, turmeric, common algal pigments if we want blue, like phycocyanin. And if we try to look at our insect population, we might be able to look at colorants, because the Dactylopus coccus beetle is the source of a very deep purple, deep red colorant in South America. It is a beetle, and you extract the colorants from it. Next slide, please. Flavors and spices: vanilla, labuyo, ginger, onion, many of these. Vanilla is a very high valued flavor, and it's an orchid, and we have very, very little participation in this trade. Next slide, please. Essential oils, ilang-ilang. We are told by the perfume industry that there is no perfume which does not contain ilang-ilang oil as a base oil. And unfortunately, we have been overtaken in this production by some of the African countries. But there are many more that we can look at for essences and perfumes. Next slide, please. The natural biopolymers, nata. I don't know if some of you have seen the most expensive headphone produced by Sony. It's $6,000, and the vibrating membrane is a very thin membrane made out of nata. And there are many other biopolymers that we can derive from our resources. Natural toxins have to be monitored for biosecurity and biosafety purposes. But let me end by saying that all of these need talent, and all of these talents need to be retained, because talent is going to be the key factor that will make a difference in our innovation and competitiveness activities. Next slide. Next slide. Our national innovation system has to be well understood, well managed, well funded, and empowered, so that the scientists can make decisions and not depend on hyper-regulated systems. If we don't change that, our reset activities will come to naught. This is a very important institutional factor, that hurdle rather, that we need to change in our regulation towards innovation. Next slide, please. So we need to accelerate the development and the retention of talent in chemistry, and they cover from chemists to chemical technicians to very skilled workers, especially for those who are pursuing advanced degrees, MS and PhD. Most of them are being trained for academe. I think we should reset part of it so that they can be trained for industry, because industry needs this if it wants to be able to cope with the requirements of product sustainability. No brain, no gain. Next slide, please. And actually, I hope you realize from the way I have discussed these concerns that everything is chemistry. Everything is chemistry. And the next slide. We have to ensure the balance of technical disciplines. Make sure that we have in the Philippines, in residence, or in our diaspora, people who will help us in analytical chemistry, organic chemistry, physical chemistry, biological chemistry, inorganic chemistry, and polymer chemistry. I have looked at your posters, and I see there is very little being done in inorganic chemistry as far as the posters are concerned. I hope that is not reflective of the kind of attention it is being given in our instructional program, both at the undergraduate and graduate level. Next slide, please. There are also applied areas of chemistry, which you are all familiar with, and many of you come from many of these sectors. Next slide, please. But we must not forget to make sure we continue to undertake fundamental research, because that is the basis for innovation, the basis of new knowledge. Unless we know what is at the molecular level happening, it is not possible for us to manage it effectively. Finally, just to make sure we are aware of the cycles of the products in the value chain, we need to be able to kind of develop our own niches so that we can monitor the impact of the molecules we produce in each of the stages of the value, the global value chain and our local value chain. I hope this, next slide please. I hope this brief presentation has given you some additional thoughts, and thank you for the opportunity to share, and thank you for listening.
Okay.
Thank you very much, Dr. Padolina, for.
So I hope you learned something. Okay. The end message of Dr. Padolina there is the need for the manpower, and that manpower is you. Okay. So I hope this course will help you to at least tackle some of the problems that were presented by Dr. Padolina. So that's the main goal that I said, oh, maybe it's Dr. Padolina. So maybe my students will be aware of what is happening around our country. Okay, kasi minsan masyado tayong focus doon sa science. Medyo unstable yung ano ko. Pag nagsasabi sa akin na unstable, nagpo-post ako for a while. Okay? So I'm aware that mag-aano din yung internet ko. So the main goal, as I have told you, is at least so you will be aware what are the possible problems that our country has and how are you going to be able to tackle them and be of help. That's the main purpose why I showed you that thing. So today, what I'm going to do is just to tackle to you the chromatographic experience that I have. So the way Ma'am Ivy and I are doing it, we leave you with reading the modules. But since I'm also teaching Chem 137 this semester there in UPLB, once I recorded my lecture about chromatography, in case you didn't took your undergrad in UPLB, so I will give access to that recorded lecture that I'm going to prepare in 137, because the way, as Ma'am Ivy and I told you during the time, we don't usually have lectures here, formal lectures. So the way that we do is we're just given a problem from experiment, okay, and then at the end, at least you will be able to train how you're going to formulate a proposal to a problem, okay, that is given to you. So that's the main goal of this course. So what I'm going to do today is just discuss to you my so-called chromatographic experience. Okay. So you should be able to see my slide there. So when did I first encounter chromatography? So I would say this is the summary of my chromatographic journey. So the beginning that I have there was way back in BS thesis, and then I took Chem 230. So way back in BS thesis, I do GCFID, but I'm not the one who did it. Okay, HPLC was the one that I used using fluorescence detector, and then during my PhD years, I used LCMS, and then the PI years, that's not what you think what it is. That's a principal investigator years. So I use an HPLC, a mass spec, and a GCMS. Okay. So as I've told you, the first encounter that I have was during my BS thesis. So my topic is about neem. Okay. I don't know if you're familiar with the neem tree or the neem plant, Azadirachta indica. So I was working in NCPC, National Crop Protection Center. So I'm trying to analyze the insecticidal activity of the neem tree. So the way that we have the partial characterization of something. So the way I do is I extract it using different solvent. So test the different solvent for activity, and then try to characterize, okay, the solvent that is most active. So the one that we found most active are the non-polar one. So we don't have GCFID during that time. GCFID is just one of the method that we use. But there's a company that is starting during that time that I think right now is a well-established company. I'm not sure if you know JEPCOR by Ma'am Edna Mijares. So there's a student last semester was working there in JEPCOR. So since Ma'am Edna was working in NCPC before, okay, she's kind enough to analyze the sample that I have. So all I know is I have a flame ionization detector that was used. I didn't analyze it. I just sent it, but I was able to went to their lab. I think it's Sukat Taguig area. It's near the DOST that we have now. But aside from GCFID, I also analyze it using IR, and I think the one that I use is with Ma'am Irma Panalangin, okay, from FPRDI. We have IR during that time, but the one in charge, the faculty in charge, won't allow us to use it, and I think it was not even what we call maximizing its use. I remember they have to install 2 air cons so that they can alternate the air con for maintenance of the instrument. So that's the first encounter that I have with the chromatography. Okay, so this is aside from getting a course like Chem 137, 137.1, okay, where you do experiments on chromatography. And the next time I encounter chromatography was when we were asked to do a research topic. Okay, so we have a Simadsu HPLC. I'm not sure if it's still existing there in UP Los Baños. So what we did, so we have a group, okay, just like the grouping that you have right now. So the three of us, upon the suggestion of our professor during that time, Ma'am Emma Clavier, so asked us, oh, why don't you try to work on the PAH, the polyaromatic hydrocarbons? Since we cannot afford to buy the 16 standards, okay? So we just find what is available during that time. So we have this anthracene and penanthrene, and we try to monitor their presence in banana chip or yung tinatawag na pinasugbo, okay? Because the idea there is they're made up of honey. If they're heated, one of the products or byproducts that form are these PAH, which was found to be carcinogenic, like your benzopyrene. Now, I'm so happy with the research topic that we have here because we're able to present, okay, a poster paper. So the group mate that I have here is with Dr. Loreto, who is now in Visayas University. No, is that Leyte State University, the former BISCA, Visayas College of Agriculture, I think. And then Miss Oncog, she is from Visayas. And of course, Mantlabyer. And then I continue doing it until I was able to present a poster paper in the 17th Philippine Chemistry Congress in Cagayan de Oro. So that's why I can tell you that I have fond memories of this Philippine Chemistry Congress. The first one that I did is in Cebu way back in 1998. And I think 2001 was the last one because the one in 2002 was in Iloilo was canceled because of SARS. Okay. And then after that, since I already got married, wala na akong pera to go or to attend. Although the university reimbursed what we call the trip expenses. Okay. So I was really happy. I remember using a fluorescence detector. So there's an excitation wavelength and an emission wavelength that we use for that. Okay, so that's the beginning of my what we called chromatography. But as I have told you, I went to electroanalytical with Dr. Joey Santos, is Earth Group there in UP Los Baños. Okay, and then when I went here in the US, I was able to use two LCMS. Okay, one is the ion trap, which is for structural determination, and the other one is a quadruple, okay, the triple quad. So this is more for analysis, okay. So for 5 years, I have access to these two instruments. We're the one in charge of maintaining it, okay. And if I'm not mistaken, the Philippines right now, they have 3 LCMS. All of them are what we call near the UP campuses, and I was able to visit most of them. So the one in UP Los Baños is the one near, I forgot the area. Is that the APEC part? The one near NCPC, okay? Because the one who is in charge before, there was a former student of mine, but I'm not sure if she's still in charge. So that's the one handled by the younger Padolina Isagani. And then the other one is UP Manila, which is handled by my friend, Dr. Frank Hilario, Frank Heralde. And then another one in UP Diliman, which is what we call handled by Dr. Ias Unyo and Isa Yu. So I know who has the LCMS there. And what I heard, I'm not sure if it's true. I think Dr. Completo is also proposing to have LCMS there in Institute of Chemistry, UP Los Baños. Okay, so the one that I use, the so-called ion trap. So it's just structure elucidation. So we're trying to determine the structure of a compound. So maybe the one that you're common here is the glutathione, right? Yung except the whitening skin product that you have there in the Philippines. So what we're trying to do here is we have this N-methyl malimide. Okay, it's an oxidizing agent. So we try to determine what happened because the glutathione is some sort of a protective mechanisms in most of the bacteria. So the way that we do it is we get this sludge. So sludge is just some sort of wastewater plant. And then we introduce the NEM. And once we introduce the NEM, we what we call lysis the cell, or lyse the cell. So to break it down and determine what happened. So in our what we call control thing here, the one that was shocked, okay, line B and line C, we find something out of it. Okay, there's a peak that coming out compared to the one that is what we call the control, the one that doesn't have the NEM. So that's supposed to be just due to the introduction of NEM. And when we try to determine what it is, so we're able to find this formula. Okay, and the way that we have used the in vitro, the Pristo sample, and then the Pristo sample. So we're trying to look at some of the mass to charge ions. And from that mass to charge ions, we try to determine what products that we have. So the 433 that we have here, that's the NEM glutathione conjugate. Okay, so the way that we look at is your glutathione combined with NEM to produce that one. And this breakdown to give us the product. So this breakdown to give us the product that has a mass to charge ion of 187 and 144. Okay, it's really a very good experience. You're like a detective trying to come up, okay, trying to solve a puzzle. So how does the structure looks like? So you're playing with the mass to charge ions that you have. Okay, and then the next time that I use it is I was just asked to analyze, okay, what happened to the tetracycline when it was added in a pinto bean. So the way that the setup would look like, there's a growing pinto bean plants, and what I did is I soaked one of the plant with tetracycline solution, which is an antibiotic, and the other one with no tetracycline. So what we're trying to do is, there's a report that tetracycline would bind with calcium. That's why they said if you take tetracycline, your teeth will glow or will become yellow because of the tetracycline calcium complex that form. So what we're trying to do there, so aside from LCMS, I also use another method known as fluorescence. So I look at the extract and I found out that the one that was treated, okay, has a higher fluorescence compared to the one that's not treated. That's the chlorotetracycline. Okay, and the way that we monitor it here is we're able to see that the pinto bean, okay, was able to absorb the tetracycline solution where it was soaked. Okay, so we're able to find using this ion trap the structure. So all we need to do is just get. So if we find this one 462 427, so we want to fragment them and see if the fragment that they have, okay, is the same as the structure that is given. So what's the difference between 427 and 410? So that's just 17. So what could be the functional group that is around 17? Okay, isn't it OH? So that's the way we do the fragmentation pattern. So this one 462 and 444. So this is just what we call 18. So we could say just H2O. Okay, so that's how we do the mass spec. So we get a paper for this one, and then another one, same problem but different species. I'm not sure if you're familiar with Arabidopsis. Okay, Arabidopsis, I think they use it in most study because it has a very low, short life cycle. I think 30 days from growth to from the time it germinate until its full growth. It's only 30 days you can do that. So the same stuff that we do, okay, put Arabidopsis in a tetracycline solution and then try to see if it's going to be absorbed. Okay, and we found out the same results as the one in Arabidopsis. So I was lucky. I was able to be part of this publication. Sabit lang ako dito. But at least that's still a paper. Eh, kahit sabit ka lang, kahit ikaw yung nasa gitna or dito, ikaw yung pangalawa. Ang mahalaga may nagawa ka. Okay? Now, my main dissertation that we have, that I did is preparing materials that use as solid phase extraction. So I prepared like molecular imprinted serogel, not polymer. So molecular imprinted polymer is organic. When you say molecular imprinted serogel, it's more inorganic. Like glass-like property. So sabi ni Dr. Padolina, wala daw tayo sa inorganic. So what I did is I imprinted the tetracycline on it, and we tried to determine if there's an imprint of the tetracycline that happened. So what I did is I monitor while the serogel is being aged. Okay, and we found out when we tried to remove the tetracycline out of the imprinted material, there's some changes that's happening. So from this originally here, so a TC solution here, so after several days of removing the tetracycline from the material, we found out that the absorbance is changing. So that means something is what we call changing within the matrix of the serogel. Okay, so we found it with an acid. We tried it with one acid, and it has the same absorbance as this one. So what we did is we tried to monitor using LCMS, and what we found out, okay, the TC solution that we have here, after several days, it's getting lower. So that means the tetracycline is changing. Okay, so the same thing with the other stuff that we have here. So when we try to look at the one that is the end cup, so we just want to end cup because we don't want siloxanes to be some of the materials that we have there. So we found out this thing, which is around 427. And we investigate, okay, the 427 that we have there is just the anhydro or the Fe anhydro. So the tetracycline can shift to 4-Fe tetracycline, which both of them can transform, okay, into the anhydro tetracycline. Okay, so we did this commercialized molecular imprinted polymer that has become very popular, because what happened is there are some of these so-called emerging contaminants. Okay, so the EPA want to develop some standard method to analyze them, but the problem with these emerging contaminants, their concentration is so low. So you have to do some sample preparation method. You cannot just analyze directly or extract, let's say, a soil sample, and hopefully some of these target analytes are there. So sometimes you have some material, you need to use some materials wherein when you pass your sample, it will just extract the target analyte that you want, which is usually present in small amount. Okay, so that leads to this non-steroidal anti-inflammatory drugs. So if you're not familiar with this one, this is your ibuprofen, naproxen, and acetaminophen, which I think in the Philippines is known as paracetamol. Okay, so those are the things that we have. So I worked with an undergrad while I was a PhD student. we look at this, what we call chloramphenicol, okay? So I have with the student who work also with other antibiotics like fluoroquinolone, norfloxacin, enterofloxacin, ciprofloxacin, and sarafloxacin. So we use a commercially available fluoroquinolones, okay? So we use this molecular imprinted solid phase extraction. So we condition first the MIP products, and then we load it with the sample, and then we wash it, and then we elute. So the way that we do it, when we condition it, when we pass the sample, it will collect our target analyte. And then when we wash it, it's going to remove the non-target analyte. And then when we elute it, we recover our target analyte. And the only way we can monitor them is using the triple quad instrument. So we just have this, what we call the mass to charge ion ratio that is signature for each of these fluoroquinolone. Okay, the data that we have is still there. We're not able to what we call publish it. It was rejected, and I was graduating during that time. Okay, but these are the things that we observed. Okay, the peak that came out when we have an enterofloxacin, sarafloxacin, ciprofloxacin, and norfloxacin. Okay, and then we also work with chloramphenicol, the one that they use as pesticide in honey. Okay, and then when I moved to New York and start as an assistant professor, so we have a mass spec there. Okay, so the thing that I did, I got some propolis sample that we have there. So we dissolve it in ethanol. So we get the two modes of the mass spec. So when you have two modes, usually is the molecular weight -1 if it's negative mode. If it's positive mode, the molecular weight +1. Okay, so as you could see that this is just ethanol, but you could see different peaks with the different mass to charge ions in this one. So we get a sample of this propolis from UPLB. So this is how it looks like. It has some mass to charge ion there. And then the one in the positive mode. So we're hoping that we're going to partner with something here. Okay, but there's one that's 171. It's always consistent whether it is negative or positive mode. Okay. Pag nagsabi na unstable, nag-stop din ako. And then we have a Bicol negative mode and then a Bicol positive mode. So the sample came from Bicol. Okay. And then we have a Tayabas, which is from Quezon, negative mode and positive mode. And in fact, I gave the data that I have here with one of the IC faculty to finish a paper because we're able to write a paper about the spectroscopy of this same sample. Okay. Now I also analyzed this T. So when we say RRG, so that's Rita Ritz Guyabano. So this is the positive mode of the Rita Ritz Guyabano. We get the Rita Ritz Guyabano also in negative mode. And then we also look at the other Guyabano brand, which is the ST. I think it's Star T something. Or simply T, I think. Okay. And this is what we call the negative mode. So I think we're consistent with the negative mode of whatever Guyabano brand or Guyabano tea that we have from different brands. Okay, that's the consistent that we have here. Okay. The idea that we have there is to compare them with the phenolics that was reported. So this is a routine and naringin standards that I run. So you always have the 211.1. So as we always said, oh, could it be one of the phenolics or whatever it is? Okay. And during that time, I also did molecular imprinted polymer. So this is the HPLC that we have. So the one that we do is because we have a forensic science program at Pace University. I asked my colleague who have access to the illicit drugs if I can do this analysis. So there's two commercially available MIP. So the one that as a student is the one that I can really trust, that is not going to mess up with the sample. So there's an amphetamine and methamphetamine. So the idea that we have is we try to monitor if we can use this as a good, just extracting material. But unfortunately, we were only using HPLC. Okay, so what we did, we ran both standards, and then to identify which is amphetamine and which is methamphetamine. So this is the amphetamine. When we run just the amphetamine, I'll just let them pass. The one thing. And this is the methamphetamine. Okay, and then we compare. Okay, so if we have a solution, let's see how much of this solution we can recover. Okay, so this is a synthetic urine. So we spike the synthetic urine with the standards, and then we have just water. Now, as you could see, I think the presence of the other compounds in synthetic urine caused this so-called matrix effect. So that signal is much lower compared to this one, but they're supposed to have the same concentration. And when we try to recover it, this one using the first run of the MIP, and this one during the second run, we found out that maybe, okay, we already get the maximum binding sites of this MIP. And the only way for us to have a successful extraction here, if we use a more sensitive LC. So we're talking about LCMS, which unfortunately we don't have. But we're able to prove there that it works, okay, because it was able to bind to recover something. It just happened that maybe the 1 ppm that we use is just too much, okay, over the binding site. So we might overload it, but we cannot go lower than 1 ppm because we cannot detect the signal, okay. And then I have some students. So we try to use nanomaterials as remediating materials. So we work with tetracycline. So we use oxytetracycline and doxycycline. So one student developed this isocratic method. So we were able to find out so one student's able to develop this isocratic method. So she was able to find out that the oxytetracyclines elute first compared to the doxycycline. And when we analyzed, I don't have the data here, some of the materials bind with the nanoceramic. So what I have here is the other type of antibiotics done by another student. So she used a sulfa antibiotics. So she has here sulfamethoxazole. So this is, we could say, the sulfamethoxazole solution. Now, when it was mixed with nanomaterials, okay, the signal that we found is much lower. So if you're going to look at here, okay, so maybe you will see, oh, it's still 20. This is still 20, but if you're going to look at this, this is what, over 20. And when we do it here, it's just around 20. So there's a reduction of the sulfamethoxazole content in the solution when you mix it with zinc oxide. So right now we have the data, but we're still what we call finalizing it because most of them has already left. Because the goal that I always tell them is if you want to leave some sort of a legacy, paper is the best way to do it. Okay, so this is our GCMS. So this is the old one that we have been using, and this is the new one that we have not used yet. Okay, I don't know when we're going to use it. It's almost a year now since it was installed because it's pandemic. We seldom go to the campus, but right now I have 4 days that needs to be in the campus, so we might use it one of these days. So one of the students that use it is a grantee or let's say one who got a grant to work on this so-called Billion Oyster project. Okay, so the goal of the Billion Oyster project is to put back oyster in New York Harbor. Okay, because oysters serve as what we call janitor, or not really janitor, like a filtering system. So what it do, it clean any water system. So what we did here is there's some these so-called restoration sites. So what I asked my students is to collect sample from this restoration site. So in one of the samples that she has collected, these are the compounds that we were able to identify using GCMS. Okay, so she's already graduated. She's now in OSHMI, Office of Chief Medical Examiner here in New York. She is a forensic science major, and she was able to have a paper on this one. Okay, and then another student, this one in propolis. So what we're trying to do is we just compare the different extraction methods. Okay, so here is showing here the one that was extracted using sonication, and then here using microwave, and then here using the classic soaking method. So they just use GCMS as one method to compare them. They use also absorbance and fluorescence. And then the same students that we have there, this time we try to compare the accelerated solvent extraction. Okay, so we also analyze it using GCMS. Then another students, he tried to work on different extract from pollen samples that came from Calamba. Okay, so what he did is he had this bee pollen samples, and then he soak it in different solvent and then get the GCMS of that. And this is what he found out. So the ethanol extract, they have this hexadecanoic acid and the esters, which was also found in the methanol extract. Now, for the dichloromethane, we just find them to be long chain hydrocarbon. Okay, so for the dichloromethane, we just find them to be long chain hydrocarbon. The same thing in the chloroform extract and the hexane extract. Okay, because they're just non-polar solvents. And I think that's all that I have right now with regards to the chromatographic experience that I have. Question? Tanong? May tanong? Question? Question? So are you familiar with this? Familiar ba kayo dito? Do you see the multidimensional separations? Because this is what you're going to do. So as you could see here, there are different what we call compounds that you have. Nasa module nyo yan. Because what we're going to do, we're going to assign each group, the two groups, with compounds. And then what you're going to do, I think you're going to determine the optimized condition that you can separate them. So for instance, I want to look at, let's say, the BTEX. Nasaan yung benzene? Ethylene. So yan yung BTEX, right? So initially meron kayong ganito, but if you're going to look at it, you can modify the thing that you have here. So what if it's gradient? So how are you going to improve it? Okay, so if it's gradient like this one, so what do you need to do? So maybe I can change the one here. Nag-i-improve pa? So mukhang, so if you're going to make this, so hindi siya nag-i-improve. So maybe I can change this one to methanol. Is there any improvement? Nope. Acetylnitrile. So this is the one that, so if I do an isoprotic here, so maybe if I change the solvent fraction here, so you will see some changes that you have. So the goal that you have is, depending on the group of compounds that will be given to you, you're going to present the group, okay? What's the best optimized condition? So this is more on simulation. Now, there are some conditions that you can play around. So maybe this one, the temperature, okay? So if you want to do, there's preset here, but they only have C18 as the one that we have here. And then you have here solvent also. I think solvent A is always water. B is what we call between acetylnitrile and methanol. So the idea there is maybe the way that you want to present it orally. So one group member will talk something about the compounds that were given to you. The other one will see what's the importance of doing the separation method. And then the other one will say, oh, this is the conditions that we play. And based on the different condition, this is the best condition to separate them. Okay. So that's the goal. Okay. That's the goal that you have there. So this one, I just used PTEX, but I don't know BTEX is good in HPLC. Okay, because one of the experiments that I do here, BTEX, but we use GCMS. Okay, because BTEX are all non-polar. maybe for me, if I'm given B text, if I want to justify, I can use an isocratic illusion. So you see this one? I think this is the best condition that I have. And my justification here, I could see the separation. Okay, although it takes you what, 4.5. So you can, if you can go shorter than 4.5, let's say, well, this one is getting longer, then you have to justify it. So maybe you could say, oh, at 65 solvent B, acetonitrile, this is the best condition that I have. I can run it in just 2.4 minutes. Question, I want you to play around with it. Familiarize yourself.
Hi, sir. Question po.
Sure.
For a specific set of compounds po, ang katulad po sa exercise namin, will we follow a standard method or
Yeah, this one.
we'll just use, okay, sir. We'll just use this simulator po for checking the optimal conditions.
You don't need to use, you don't need to perform it. You just use the simulator. So ibibigyan lang namin kayo bawat group ng set of compounds. So for now, let's say as my what we call example, I use the B-tex. And for me, I would say this is the best condition. So the idea here is, how did you arrive in getting the best condition? For me, this is the best condition, 2.4 minutes, and then at least there's a separation here between the third and the fourth peak.
Okay po, sir. Thank you.
So essentially what would happen is you would do an oral presentation on this, and then the rubrics that would be applied is already in the course site. So may story pa din. You just don't give us this is how we separated.
Yeah.
So what are the importance? So you should have an introduction.
Yep.
Why, even if we've given you the materials or the compounds, you have to make a story.
Yep.
It's like an example is like, this is what you are going to study, why this set of compounds are important in the industry or in the academe, what makes it what makes it
Important.
significant for
Yeah.
your study, yeah. And then also what makes it relevant. So lagi may story, may introduction pa rin. You cannot jump. Yes, you cannot jump into, okay, this is what we do. It's supposed to be a research for a particular set of compounds that has this significance in the chemical industry.
Yep.
So it might be, ito ang application ng mga compounds na to, ito yung na-observe na to, ito mga to ay pollutants, etc., etc. Now, the concept behind the story is up to you. So it is up to the group. Ito ang gusto naming focus. For example, last semester, ang focus ng isang grupo is on the methodology. Yung parang medyo may computational and statistical
Yep.
application on top of how they how they separated the chemicals. Yun ang kanilang backstory. Ang backstory nung isang group is yung potential harmful effects ng group of compounds na binigay namin.
Yeah.
So, it depends on the group what they want to focus on. So, yun ang inyong introduction. Ang methodology, of course, the methodology need not be presented. What your methodology would entail would depend on, again, your story. Pretend that you have these 3 compounds obtained by HPLC, and then you want to optimize their separation. Yun ang main objective nyo. But the backstory, it depends on you.
Yep.
The analysis of the data, again, it depends on you. And the group last semester, yun nga yung medyo may computational. So medyo nag-add sila ng analysis ng data nila na with statistics and everything. So depende. Yung isang group, ang kanilang analysis is more on really the separation.
Yeah.
So it depends on the group what you have, but what you have decided as a group na ito ang focus natin, ito ang gagawin, ito ang ating theme, kumbaga. So yon ang inyong major project for this particular activity. So gagamitin ang simulation para ma-separate ang compounds. Bibigyan kayo ng ilang compounds, and then you have to justify why did you choose this particular selectivity factor? Why did you choose this particular partition coefficient? So, yun yung titingnan namin. Na-separate ba? Again, there is no deciding one factor that we are not expecting one specific na, ito dapat ang sagot nila. No, because it depends on how you would defend your choice of separation. Kung halimbawa, ang topic nyo is, we want to focus on just this particular compound, then defend it to us. That is why you chose this particular optimization. Ganun po ang mangyayari sa ating oral report. Yan po ay for the oral report. Remember, mas malinaw na po yung goal ng exercise. Yes, yun naman ang goal talaga ng exercise kasi wala tayong experiment. Okay? Wala tayong experiment. Kung mag-experiment tayo, ganun pa rin naman ang goal nyo, di ba? Magko-collect ka ng sample, magde-determine ka ng set of compounds. Pag nilagay natin sa HPLC, gusto natin separated yung compounds para makita natin halimbawa yung concentration. So the goal, even if it's hypothetical, if it's just simulation, is the same. Walang nabago with regards to, except that, of course, you cannot do the experiment.
Yep.
So itong simulation na to, this is very useful if you are going to actually do a certain experiment kasi hindi ka na mag-waste ng chemicals, hindi ka mag-waste ng standards kasi you know that you have this particular standards, ito ang gusto mong i-focus, pwede mong i-run si simulation so that pagdating mag-experiment ka, di ba? Yun na lang ang gagawin mo. I-apply mo yung optimization na nakita mo and then try to see if it's in practical terms, is it applicable? Yun po ang magiging purpose ng simulation na ito. Okay po?
Now, to tell you frankly, those peaks, they're not only theoretical, they are based on real chromatograms that was obtained by that column. So they were reported in literature. So question. Familiar na kayo? I want you to be familiar with the simulator. before we assign you the grouping. So what group of compounds one group will analyze and what group of compounds the other group will analyze. Question? So mag-grouping na tayo. So one group, I would say, will have this, the paraben. Are you familiar what parabens are? Anyone?
Ang girls, di nyo alam ang paraben?
Gusto niyo kumuha ako ng sample ng paraben dito sa bahay ko? So you will know what it is. And the other one would be any of the phenone. So maybe there are several phenones here, but to be fair, siguro 4 or whatever phenones do you think is the most important? So paano gagawin natin? Magbato-bato pick kayo? Kung sino yung mananalo, siya yung mag-choose. So one is the paraben and the other one is the phenols. Hindi lang yung sample ko. Are you familiar with this? So nakalagay dyan, ewan ko kung makikita nyo. Kita nyo yan? Paraben free. So, ibig sabihin, nasa shampoo siya dati. Now, what makes them harmful or toxic? So, ganun yung parang magiging introduction ninyo doon sa oral presentation. And then, what's the need? You can include literature about LC nung paraben. Okay, if you can find. Okay, parang ano lang, yung expand nyo lang yung knowledge niyo. It's just like you're asked by a company to present, okay, give us the best optimized condition to present this. Hindi lang naman dapat diretso doon eh. Dapat mag-aano ka muna, intro, as like what Man Ivy said, ano ba yung uses niyan, so bakit kailangan i-separate. And you should give some sort of idea kung ano ba yung level niya na consider siya toxic or what we call not toxic. So ganun din sa phenol. So how are we going to make the decision? Magbabato-bato pick yung dalawang group? I think you were already sent your grouping. So who will be the leader on one group and the other group? So alin yung team paraben at saka team phenol? Pag gusto niyo, kami na lang ni Ma'am Ivy. I think one group is more than the other kasi kung mas more than yung isa, ibibigay namin yung mas marami, which is the phenon, to be fair. Para fair naman. So mas maraming members, so doon yun yung mas maraming sample. Yeah, if you let me decide, okay, so the phenon will go to the one that has the 4 members, and then the paraben will go to the one that has 3 members. Kasi i-include na natin yung, if you're going to look at the sample here, the phenons is just more than 4. I think 1 phenon here, benzo, you have the propio, butyr, balero, hexano, hepto. So ibibigay na namin doon sa mas maraming members. So maybe you can show the structure, ano bang pinagkaiba ng propio, butyr, baler, hexa, and hepta, and octa. I think it's just the number of carbons that they have there. Okay. So okay ba yun?
Okay na daw po.
Okay na yun. So, kaya in 2 weeks, ma-present?
Actually, sir, sa ating schedule,
Then
parang
next
dun
week
sa, tingnan natin yung schedule. Parang sa schedule natin ay, ano nga, tawag dito, 2 weeks, usually after every data presentation. Halimbawa, nabigyan natin sa kanila yung data, tapos they have parang dun sa atin, they have 1 week. Tingnan ko ulit yung schedule. They have 1 week to 1 week for the oral presentation, 2 weeks for the
write-up.
Write-up. Yung write-up, 'di ba sir, magbibigay ka ng ibang
Meron
data?
tayong yung
Yeah, may ibang data si sir na ibibigay. So, this is what we did last semester. Meron kaming iba yung topic for oral presentation, and then iba yung topic for the write-up. Iba yung written report topic, iba yung written report topic, iisa for both groups. Etong oral presentation ay magkaiba kayo ng as you can see, magkaiba kayo ng materials, magkaiba kayo ng compounds. But for the written report, iisa po ang ating data. Ayan. So, kay sir tayo manghihingi ng data, as you know, again, dahil wala naman tayong opportunity para mag-lab. So, ayan po. Kay sir yon manggagaling. Based on our schedule, ay yun nga po, oral report is October 1. Ano bang date niya? 20, oral report is next week. Tapos yung written report ay October 4.
Kaya ba next week?
So, kung hindi kaya, ibig sabihin lang, ang mangyayari, dalawa yung due ng October 4. Yung oral representation and yung written report. It doesn't matter to us. Kasi ang sa amin naman is, yung written report, that means we do not have any meeting on that day. Yung oral report naman ang kailangan na meron tayong synchronous class kasi kailangan yung mag-report. So kayo ang bahala kung ano.
By group ang oral report.
Yes,
Kahit yung, kahit yung
Ay.
written report by group din.
Ay, hindi,
Ay, di
hindi
ba?
nyo tinignan ng ano, hindi nyo
Hindi
tinignan
nagbabasa
ang
module.
course guide. Ay, nako, nagpakahirap pa naman ako ng course guide, ng course site, ng calendar.
Nandun
Ay,
lahat.
tingnan po. Nako.
No, anything goes. Pero siguro, mga 1 hour per group para makatulog ako before 12.
Correct.
Kasi last time, I think one of them presented 1.5, I think 90 minutes.
So, ano na lang, let's be reasonable. Hindi naman ito ay defense ng thesis. Ito ay presentation ng data. So, that means, hindi kailangan ng 1.5 hours or 2 hours na presentation. So, limit your presentation to up to maximum lang ng 1 hour. Ang hint ko po lagi whenever we do presentation is that I should spend 1 minute per slide. Yon. At least yon. Syempre, kung halimbawa ang isang slide mo ay all about the explanation, so of course you would spend more time on it. But if you have, for example, 60 slides and you're expecting that you'd spend more time in 1 or 2 slides, so obviously parang hindi na yan mag-fit sa iyong 60 minutes. Ayan. Kasi po, again, when you do presentation, sa Philippines kasi hindi masyadong mahigpit sa ganyan, 'di ba? Parang I think also in the US, parang kahit binigyan na, okay, you have to present for just this couple of minutes, ganyan, they could extend. So, kaya ang nangyayari sa ating mga conferences, parang 5 o'clock, pero 6 o'clock, pa rin tapos. Kasi laging, if every presenter would extend, hindi talaga matatapos on time. But not in the case for Japan. Sa Japan, pag sinabi nila that your presentation is 10 minutes, that's just 10 minutes. I had one presentation na, it was a conference. There is poster presentation and oral presentation. You have to present first your oral presentation, and then you tell the audience that this is where they would find your poster. So if they have any questions, pupuntahan yung poster mo. Tapos parang ano lang din yun, defense. I forgot kung 10 or 15 minutes. Basta ganun lang. So I just have 7 slides. Anong na-present ko? Na-present ko lahat. Kasi nga, ganun sila ka-strict. Pag meron yun, even for defense ng students, pag oral defense ng kanilang masters, kahit ng PhD, allowed lang ako ay 1 hour. Napagalitan pa ako kasi nung final defense na parang sabi nung isang panel ko, you took longer today. Kung tutusin, parang formality na lang ang final defense, yung parang initial or mid-term defense, yung parang talagang madugo. Kasi pinaganda ko yung presentation, ganyan. Hindi na pala nila kailangan yun. Kasi essentially nga, kailangan ko lang i-present dahil graduate na ako. But in masters, sila, may bell. Pag 3 minutes na lang, kasi 3 minutes na lang yung remaining para sa questions, ganyan, kasama na yon, magre-ring yon. Tapos, 3 beses magre-ring yung bell. Parang kung 3 minutes, kung 2 minutes, tapos kung 1 minute. Tapos pag 1 minute, finish, parang ganun. Pag finish or not finish, they would tell you, the moderator would tell you, you need to wrap it up. Ganun po. So, I want you to learn how to do that.
Yeah.
Kasi ako ay nahirapan nung pagdating ko sa sa Japan, kasi syempre sa Japan din, it's not similar to the US that everyone is very fluent in English, and everyone can understand even if you speak so fast in English. In in Japan, ang sabi nung isang advisor ko, because in our research group, pag may presentation, kahit sino, kahit PhD ka, kahit undergrad, or kahit master student, may practice kami. So parang isasabihin namin na, tatanong ng mga professor, ilang minutes ang presentation mo? Tapos sasabihin namin ganito. Okay, so expected ka na ganyan. So part yon ng training namin nun. So sasabihin sa amin na, okay, so you start, ganyan-ganyan. Tapos nung natapos ako, nag-practice kasi nga ako, ganyan. That was the first time that I made a script for a presentation. Usually, what we do is we just have our slides and then we just talk about what we want to talk about. But not in Japan. In Japan, you have to have a script because you need to stick to the time. All right. Yes,
think
it depends. Yeah. What we did
follow the
is
rule. I mean
lahat.
the time rule.
Yeah, yung time rule,
Kasi
I think that's important. as of-
napansin ko pag Pilipinas yung nag-host talagang overtawad lagi
parang walang consequence of time na
Yeah.
parang sige, pwedeng magganito. But that isn't the case in other
No.
countries. You have to stick to, if you
Yeah.
are given 1 hour, then it's just 1 hour. Pag sinabi pa sa inyo, kasama na ba yan ng question and answer portion?
Yeah,
Pwedeng
we will
hindi,
do that.
pwedeng oo, yan. Siyempre, sinasabi naman yun.
Kasi
But yeah,
yun yung napansin ko whenever I attend, like yan, yung PCC, sabihin ko sa iyo, laging overtawad mga yan.
kasi nga, yun. I think nasa training din nga kasi. And that is why nahihirapan ang mga Pilipino for example, sa Japan, pag nagpunta talaga, parang, bakit ganun? 10 minutes? Sanay na sanay tayo na okay lang mag-extend. So, tapos ang sasabihin pa nila, sinabi pa nun sa akin ng professor, please adhere to the time,
Yep.
but speak slowly. Sabi ko sa sarili ko, speak slowly, tapos adhere to the time. Eh di syempre, di ba, parang nagets ko kung bakit sinabi niya na speak slowly kasi sabi niya, not all the undergrads are very good in English kasi sa research lab namin, meron na kaming undergrad members. So, syempre, hindi pa sila ganun kagaling sa English. Pero yun ang sasabihin nila, you have to speak clearly, you have to speak slowly, but you have to present everything in a particular time. And that takes skill. So, kung kayo ay may planong mag-abroad, I think it would benefit you really if
That's true.
you adhere dun sa time na sinabi sa inyo. Kasi mas okay na yun na, thank you for adhering to the time kasi kesa yun sa mag-apologize sa I'm sorry that I think I have extended, ganyan. So, always design your presentation, oral presentation, to the time that is set to you. Kasi hindi lahat din ay yung availability ba, lalo na ngayon. Kasi ngayon, one can have a next Zoom meeting na
That's
mag-start ng ganitong oras, pero ikaw hindi ka pa tapos, paano makakaalis yung audience
Yep.
mo? Parang ganun.
Kasi
So, ayan po.
ang experience ko dito with ACS, they're giving us 15 minutes everything, 12 minutes yung talk, 3 minutes yung Q&A. And then usually pag 10 minutes na may magtataas ng 2 minutes more, like ganon. Ang napansin ko lang kasi when PAASE, this is the Philippine American Academy of Science and Engineering, I was so pissed off when one of the thing there, ang problema kasi kakilala ko yung nag-organize So pinauna nila yung dalawang foreigner na on time, tapos nung Pilipino na, naging 1 hour long yung extension. Okay? I told myself, if I'm the moderator, I will adhere to that time. And unfortunately, yung moderator na yun, magiging co-moderator ko ngayon sa PAASE meeting. But I'm
Sir Chapika.
Teka lang. Nag-ano kasi yung yung internet
Internet?
ko. So kapag co-moderator kami doon, I will since US yung ang host, sasabihin ko na I think we're going to stick with the time. Kasi to tell you frankly, department meeting will not go more than 1 hour. We have the right to walk out if the meeting is extended for more than 1 hour. Yun yung policy namin dito. Because I know there in the Philippines, the meeting can go on forever with no resolution. Yun yung isa sa mga natutunan ko dito, that you have to be what we call with your time. Kasi ang yung ibang tao dito, that we have other stuff to do, so we don't want to waste our time. So maybe as a training to you, what we're going to do, like a plenary, like maybe 45 to
Yes.
50 minutes talk, and then 10 minutes at the most question and answer portion. So lahat na yun magpe-present. Slides lang ang
Yes, so ang
kailangan.
submission natin for oral presentation is, of course, after you have presented, you need to submit the copy of your slides. Ganon din po ang ginawa namin requirement last semester. So you would be graded on the presentation. Again, look it up, ang ating pong rubrics na ando naman po. And then, of course, the slides itself will not be evaluated, pero kasama kasi yung presentation doon sa, syempre, how your slides look like when you present. So syempre kasama pa rin siya. Alright, so sir, bigyan nyo nga po ako ng at parang baka parang hindi sila nag-explore ng core side.
Oo nga eh. Yung isa pa, ibang account na pala to. Yan, ginawa kitang co-host dun sa isa eh. Everything, all the materials are there in the what we call course site, yung module.
So ayan po ang ating course site. Okay, andito ang ating course guide and requirements. So nandito po sa course guide how you would be graded. Diba? Na-discuss natin to last time. Ito ang ating schedule. If you look at it, supposed to be next week ang oral report. Ito kasi ay based lang din sa nangyari sa amin last regular semester, second semester. Kaya lang na-move ang mga requirements kasi nung may bumagyo, walang ganito. Tapos, ma'am, hindi po kami natapos kasi yung iba po namin subject, madami ding reports. So, siguro ang bait namin ni sir kasi kami yung nag-a-adjust para dun sa iba nilang klase. So, parang, okay, sige. Ang sa amin naman kasi, as long as you submit. The problem is this, parang, pagdating na nung end ng SEM, nandyan na lahat nung kailangan nilang isubmit ang report, and we can no longer extend beyond the finals week kasi mag-check pa kami. Di bali sana kung halimbawa this is administered, yung mga reports nyo ay administered na mag-check na lang ang Canvas. Hindi po, ito po ay binabasa naman namin ang inyong reports. Okay? So written exams, yan ay individual. Yung special topic at the end is individual. So that means 50-50. 50% would be coming from group activity. 50% would be coming from your individual output. At the end also, there would be a peer evaluation. So magbibigay ako ng sheet on peer evaluation. You would assess your group mates as well as yourself. Okay, so again, dun po meron din akong rubrics. Hindi ako yun parang, ay friend kami nito, kahit wala siyang not-contribute, bibigyan ko siya ng 10. May rubrics pa rin po akong binibigay. So, ayan. So, ito po ang ating mga with regards to the course guide. Sorry. And then, ito ang requirements. Ayan po. ito yung research paper, written report. Ayan po ang rubrics. Now, dito walang nakasulat na discussion and conclusion. Sa discussion and conclusion, magkasama na po yan, 25%. So, title is 5%, abstract 10%, introduction 15%, materials and methods 15%, results 20%, discussion and conclusion 25%, and literature cited is 10%. Okay, now this is how you would be graded on the oral presentation. Scientific level, 20%, layout 20%, message. This includes the structure, the timing, appropriateness of level for audience, 20%, presentation skills, verbal and non-verbal cues, 20%, and of course, how you discuss. So lahat naman po yan ay 20%. It's up to you. Last semester, every one of the group presented. So binigyan ng certain topics. Halimbawa, yung isang student ay introduction, yung isang student presentation ng data, tapos yung isang student ay yung kanilang results and discussion. Or for example, since this is optimization of parameters, pwede nyong ang hati is, okay, this person would focus on, for example, one parameter na inoptimize, yung isang student for one parameter na optimize, and then yung last student would be for everything. Parang recap of how they combined all the optimization and they come up with this particular. So, bahala po yun sa inyo. Work on your strengths. Ganun naman yun. Since this is group work, you should know, okay, ito maganda ko ma-explain to. Itong introduction. Maganda ko ma-explain. Ito, dahil ako ay may experience talaga sa ng chromatographic experimentation, so kaya ko ma-explain to with particular examples na ito, or we could relate this to particular examples. So work on your strengths. Kasi yun yung magiging, remember, din to, ang atin po, kami po ang mag-grade sa inyo, and this would be a group grade. So, yung success ng isang student as well as yung pagiging unsuccessful ng isang student would connote sa group assessment. So, make sure na syempre maganda ang group output. What else? May question po dito sa rubrics. What else? So dito pala sa ongoing topic, dito ko kasi nilalagay yung data na bibigay ni Sir for the written report. Okay? So dito ko usually nilalagay yung data for the written report. Yes, there is, I think nasa parang meron akong kasi I need to, hindi ko kasi kayo ma-complete. Dapat kasi merong report, merong anong tawag dito, merong sa Canvas, I could group you already, but I cannot do that kasi dalawa pa sa inyong classmates ay walang UP mail. So hindi ko masimulan yung grade book kasi yun nga, meron pang walang UP mail. Pag kasi na-group ko na kayo, parang pag nag-submit yung isang submission lang ang kailangan, ano na yon. And when I check, by group na yon yung grading na yon. So I think yung format ay, saan ko ba nalagay ang format? Dito ba? Links, nope. I-update ko to. Alam ko meron akong format dito. Miscellaneous. Nope. Meron akong binigay na format, but I will put it in the course site. Kung di ko nalagay pala dito. Alam ko na yun. Anyways, may question pa po?
Okay, share ko sa inyo yung data ng magiging written report nyo. So it's caffeine on soda. Okay. So the way that we do it, you will have a written what we call version doon sa experiment. So everyone know what caffeine is. So what we did is to analyze the amount of caffeine doon sa different soda sample. So usually we do the calibration curves wherein we use different concentration of caffeine. Now, when this was done by my students in instrumental analysis, they analyzed different concentration, and then they use this diode array detector using different wavelength. Okay, so one that is at 210, one that's 254, and the other one is at 280. So this is what we call the 10 ppm caffeine. So merong numerical value niyan dito by the end. So kung gaano kaano yung width niya, yung area, tsaka yung height. Okay? And then, when you use 25 ppm, o meron pa dito yung different ano niya, yung wavelength. Okay? So, you only select there the one that has the highest peak here, which is at 2.192, which is the caffeine. And then when you use 25 ppm, you get the same signal, but this time, okay, the area and the height are a little bit higher compared to the 10 ppm that you have here. So here you have 1650. Okay, here when it is already 25 ppm, it's around 3800 with the area. And if you have it in terms of what we call 50 ppm, so the same peak still, but the peak area and the peak height are much higher. So this is what, 6250. 6,250. Now, when you go to the samples, what do you have? You're going to have more peaks than the one that has just the caffeine standard, because there are other stuff that you have there in your sample. So this is, if I'm not mistaken, Coke. Okay. So how are you going to know that your peak is a caffeine? They usually have the same retention time. So the one that's at around 2.197. So you look at the peak area there, or the peak height. Okay. And then maybe from that one, you can determine the amount of the caffeine that you have. So we have Coke. Medyo choppy lang. We have Coke, we have Pepsi. Okay. So the same information that you have here. And then last, you have Red Bull. Now, the way that you're going to write the report here, parang nag-optimize ka rin ng condition. Alin wavelength ang gagamitin mo? Are you going to use 280, 254, or 210? And then, what are you going to use? Are you going to use the peak area or the peak height? Okay, because you can have a calibration curve. There are different concentration versus peak height or peak area. So yun yung parang magiging calibration curve mo. Yung X value is the concentration, and the Y value can either be the area or the height. And as you could see, you have different what we call peak area and peak height at different wavelength. So meron sa 210, meron sa 254 at meron sa 280. So that's what makes it a little bit challenging. But this data was generated by undergraduate students. So question, so this will be made available to you, tsaka yung write-up niya, kung ano yung condition na ginamit. Tanong?
Questions?
Yung sample prep naman, merong write-up na ibibigay sa inyo doon. Yung conditions lang na kailangan yung tingnan ay yung wavelength. Kasi 3 wavelength yung ginamit eh. Tapos, at different wavelength, meron kayong 2 basis para doon sa signal. Because the way that we look at this, what we call determination with standard or a calibration curve of standards, is we use different concentration. Now, what is the signal that we're going to use? Are we going to use the area or are we going to use the peak height? Dapat madagdagan pa yung sample. Bumili kami ng mga inkan. We want to compare Coke inkan, Coke yung litro, Coke in small. Unfortunately, nag-down yung instrument. Hindi namin makita yung rubber na kailangan niya. So ininom na lang ng mga bata yung soft drinks. Because we suspect that even if it's the same Coke, but if you have different size, they might have different what we call value. And I would say that it's also your responsibility to compare whatever the amount that was reported there sa 3 samples kaysa doon sa what we call amount na sinasabing meron siya. So that's the Coke, Pepsi, and Red Bull. So yung format ng written report nasa course site na rin. Okay. So question.
So I'll update the course site on the ongoing topic para dun sa data na ibibigay ni Sir. So dun ko na lang i-upload. I hope nakita nyo yung message ni Sir Jarien. Nakita nyo ba yon? Yung invitation for this afternoon. Okay, don't forget. Baka wala kayo in schedule yon ng librarian. So, ayan. I think yung mga may UP mail na gawan nila ng account sa Science Direct.
Wow.
So, kasi meron kaming access Open Athens. So yun na i-discuss mamaya ni Sir. So, kaya maganda yun, Open Athens, kasi maganda yun kasi makikita na nila yung mga pwedeng gawin na yung services sa library. Yan. Pati, ewan ko kung introduce niya rin yung Mendeley, pero yun. So, yan. Yan po ay mamayang alauna. Yan. Patulugin na natin si Sir. May question pa ba kayo? So, ano pala, gusto ko i-confirm, next week ba ay may mag-oral report ba o hindi? Kasi sabi ko nga sa inyo, originally, Chem 230 is on a Wednesday. We do not know how it came about na nilagay sa Monday. Monday is usually allotted sa mga faculty meetings, sa mga committee meetings ng faculty. Nahihirapan tuloy ako. 3 yung ina-attendan ko at kaninang 9 o'clock. Ang hirap mag-adjust. So, meron pa pong mga succeeding Mondays. Ang mahirap kasi sa atin, we only meet once a week. Okay lang kasi ito if we meet twice a week na pwedeng, okay, next meeting tayo mag-discuss, asynchronous tayo ngayon. Kasi yun yung ini-expect nila for the online classes. Nung sinabi sa amin na, ay right sir, nandun ka naman nung faculty meeting ng Chem, na parang although we are allowed to make an excuse letter, they are expecting that we should exhaust all exhaust all means na hindi absent sa faculty meeting. So, yun lang ang naging ko. Sabi ko kay sir, I will attend using my personal email, tapos pag available saka na lang ito. But I can only do that because Sir Elmer is here. Kung wala si Sir Elmer, ang mangyayari sa atin is mamumove lagi ang synchronous classes, and yun, yung mga presentation ng data, hindi natin yun magagawa kasi nakalagay siya sa Monday class. Ayun. So, yun po, anong desisyon ng body? Will we have a meeting next week or wala? Nagte-text siguro yung mga yan. Mag-meet ba tayo next week? Para alam na ni Sir kung siya ba ay free ng Sunday next week or hindi. Kasi ang sa schedule nga ulit natin, sige nga, ayan, may October 4 na lang po for me. Anong sabi niya mga group mates mo, Jeb?
Asynchronous.
Ikaw lang. Asynchronous kailan? Next week. Okay? So we'll give next Monday time for you to do both. Kasi ganito ang nangyari ganito ang nangyari last semester. Nag-focus sila nung first week sa oral presentation. Ganyan. So, by the next week, nag-present sila ng oral presentation. And then, the next week, submit yung written report. I did not ask for submission ng 9 o'clock. Pinasubmit ko yon at the end of the business day, 5 p.m. Okay? Kasi, ang inaano namin ni Sir, gusto rin naman namin na mag-adhere kami dun sa work hours ba? Kasi if we ask to submit ng 12 o'clock, syempre, din naman yun, mag-check ba kami ng 12 after 12 midnight? Syempre, hindi naman, di ba? Dahil tulog na kami. So, at least yung time na pag-submit nyo is yung time pa rin na, okay, sige, pwede kami mag-check. Ganyan. Alright? So, yun po ang mangyayari sa atin. Next week, we won't have a meeting. We'll ask you to prepare for both. So, October 4 would be the presentation. Start tayo ng 9 o'clock, synchronous time. If may meeting ako ng 9, na lang ulit ako. Attend ako using my personal email. Yun. And then, ayun. Ganun na lang ang mangyayari sa atin. Okay? So you have next week to work on both your oral and written presentation. I will post the... ngayon po,
Bibigay lang kami.
ibibigay sa akin ni Sir, ilalagay ko doon sa website ulit. Nope. Ayan po yung kay Sir Jarian, please don't forget. Dito, ongoing topic, dito ko po ilalagay ang data na bibigay ni Sir. Okay? Okay po. Nasagot po ba? So, sige, hayaan niyo na muna kami mag-meeting ni Sir para ma-upload yung data. We'll see you on October 4. Ano po? Eto, nandito na po. Research rubrics, oral rubrics, written full report format, adapted from 137.1. Hindi naman nagbabago kasi ang content ng ating mga full report. It's just the format that we had to follow. Paano mag-report ng... nandito na rin po ang literature cited. So, thank you to Sir Jetro for allowing me to use this. Ang binago ko lang dito ay for 137 magkasama ang results and discussion. Dito, we separate it. Kasi marami sa mga publications, tama sir, they want the results separated from the discussion. So yung results, ipe-present mo lang talaga yung data, table, ganyan. So this is what we got. The discussion is on, dito papasok yung theme ng iyong report. Na how is the data related to the theme that you want to present, that you want to focus. So kung gusto niyo pong makakita ng mga example na ganyan, maghanap po kayo ng mga papers na separate ang results and discussion. Kasi ganyan, usually yung mga ecology, ang topic yan, medyo ganan. I-result muna tapos since all of the parameters are interrelated saka yung sa discussion. So ayan po ang I put this into Word. So para pwedeng yan na yung diretso na kayo magsulat dyan. Again, ang submission po is by group. I hope, kulitin nyo sino ba magbibigay ng UP mail, kulitin nyo na please para magawan ko na yung group. Kasi ang mangyari, paano ba mangyari magiging submission? Anyways, you have 2 weeks para magkaroon kayo ng UP mail, para maayos ko yung grade book. Kasi mahirapan ako pag ginawa kong individual yung Ang ganda kasi sa Canvas, pag naka-group na kayo, ang grading sa mga group assignments ay by group. Hindi ko na kailangan i-input isa-isa. So na yun, automatic na yung pag nag-check ako ng full report or nag-check kami ng full report, oral report, kung ano yung score for that, kasama na yun sa buong group. Hindi na ako mamumroblema. And please, ano pala yung inyong ang kanilang name, team name?
Group name.
Walang nag-iisip. Mag-isip naman kayo ng ha? Oo, thousands of requests, I know. Pero, diba, parang, ang napuput off kasi is din natin, dapat kulitin nyo. Actually ako, parang halos 2 semestre yata ako na walang UP mail. Ang hirap kasi so sabi ko nga, dahil syempre wala kayong access sa course site, hindi, ako kasi wala naman akong problema kasi na-access ko yung course site. So kayo na walang UP Mail, hindi nyo na-access ang course site, hindi nyo na ma-maximize yung mga pwedeng makita sa course site. Canvas chat feature, I would suggest sa discussion na lang. Doon ako maglalagay ng discussion forum. Kasi pag ang question kasi ng isa ay question na din ng lahat, ito yung sinasabi ko rin sa undergrad. Nagfa-flood ng messages na iisa lang yung theme. So I make a discussion board such that yung question ng isa i-post doon so that it could be addressed all at the same time. Siguro na-experience nyo naman yon na lalo na yung mga students ngayon, yung freshmen, wala pang inhibitions with regards to texting, messaging teachers. Kaya nilimit ko. Actually, ang nag-allow lang ako na may group chat for class ay Chem 230 lang. Wala ako sa lahat ng aking undergrad courses kasi nga po, nagpa-flood siya ng So, we'd like to make it formal. Oo. Dun sa discussion tab, I will put a discussion forum. Diba, for experiment, for Chrome, dun na lang i-note lahat. Ngayon, yung wala pang UP Mail, if you have a question, force it through your classmate or groupmate para ma-post. Okay? So kasi dahil group work pa lang naman ngayon, si Kim at saka si Herian, you could gain access nung format kasi merong access ang inyong groupmate. So as of now, wala pa tayong problema. We would have a problem pagdating na ng exam. Kasi ang exam will be delivered through Canvas. Although it is file upload, dun po kasi hindi na mo monitor. Just this morning, ang daming change of grade ng CAS faculty kasi hindi na mo monitor hindi daw nagno-notify sa Google Classroom or something na late submission or something. Sa Canvas po, lahat kasi monitored. Once student submit in Canvas, either late, on time, or whatever, namo-monitor siya. Kaya gusto ko po sana na tayo talaga, meron na talaga tayo sa Canvas. Of course, if we have no other choice, for you, sa email ko, i-administer ang inyong exam. Pero yun nga, ang hirap nun kasi andun. Ayun nga, yung ibang teacher kanina, kaya hindi daw nag-notify, nakalimutan nila na nandun sa kanilang Google folder, yung exam submission ng mga bata. So, yan. Mahirap po, kaya gusto ko sana nasa LMS lahat ng submissions. Okay? So sana po ipag-pray baka kailangan na lang na matinding prayers para magkaroon ng UP Mail account. Kasi hindi ko maalala yung term. Lagi ko naalala ang term ay Japanese. Kumateru, it's troublesome pagka ganyan. Okay. Tingnan nyo, si Sir, wala pa rin siyang UP Mail. Isang taon na siyang, halos mag-iisang taon na si Sir na nagtuturo. Wala pa din, di ba? Actually, kami ni Sir ay hindi pa essentially, officially, member ng graduate faculty. Nag-message lang sa akin si Ma'am na wala pa daw akong appointment. So, ang sabi ni Ma'am Ami, bakit ka pinagtuturo ng 2:30? Ay, hindi ko rin na alam kung bakit ako nagtuturo ng 2:30. Okay? So, please, access the site if you can. Otherwise, Kim and Herian, rely on your groupmates para sa mga updates sa course site. Okay? So yun naman ay available naman for you, for your consumption only. Okay? I'd like to reiterate, ang Chem 230, especially the online course, this is the second time that it is offered. Ibig sabihin, yung mga topics na na-discuss namin ngayon, na-discuss ni Sir ngayon, diniscuss din yan last SEM. So, ano po ha, ang plagiarism ay nag-a-apply lalong-lalo na sa ating graduate students. Sa ating undergrad students, yan ay kailangang i-remind sa inyo po, ingrained na yan dapat na hindi natin dapat gawin. Okay? So hindi na kami nagdi-discuss na no to plagiarism. Kaya yan po. Okay, makikita naman namin kasi kung ang report nyo ay yung old report, wala naman sa aming kaso yung kung magsubmit kayo ng old report, do remember that the passing grade for a graduate student is 80%. Hindi tayo 60. 60 ang passing, 3. Pero do remember that you are bound by the standards ng graduate school. Ang passing ay 80. Yan po. Okay? So, any plagiarized work, ayan, usapan namin yan ni Sir, will automatically get a 0. Ayan po. Hindi kayo bagsak sa sa course, but the assessment itself is automatically 0. Ayan po. Okay, so patulugin na natin si Sir. Kanina ko pa sinasabi, pero salita pa rin ako ng salita. Okay? Okay na? Wala nang questions? Ay, okay. Wala nang question, clarification. Mamayang hapon 1 o'clock tayo kay Sir Jarien. Akala ko ibibigay niya ng weekend. So please, mamaya, if you could also join if you have your laptop, kasi parang ganun yung naging experience namin last semester. Pinapatry ni Sir yung parang sige, nakapag-enter na po. So talagang very hands-on yung parang workshop. Nakatry na po, nandun na po ba kayo? Ganyan si Sir Jarian last time. Okay. Okay. So, sige na.
Ladies and gentlemen.
Okay. Sige, mag-usap muna kami ni Sir. See you in 2 weeks.
Goodbye po. Thank you po.
Yes.
Okay, bye.
Thank you po.
Thank you po.
Pwede na sigurong end ng recording.
Oo. Ano na yun?
Kaya end.